We have one problem here, and it says, is 2352 a perfect square? If not, find the smallest multiple of 2352, which is a perfect square. Find the square root of the new number. Now, we don't know whether 2352 is a perfect square or not. And we know three different methods to find out whether a number is a perfect square or not. The first method is repeated subtraction of odd numbers that we rarely use because it requires a lot of steps and therefore it becomes too lengthy. The next method is by using prime factorization method, and another one is long division method. In problems like these, when you have to find the smallest multiple, or sometimes you have to divide some numbers in order to make a number perfect square, it's always, you always have to use prime factorization method, and I'll show you why. So this is 2352. Let's find out the prime factorization. Six, 16, then you have 2 to 4, 2, 9, 8 to 4, then you have 2, 1, 2, 2, 4, 8, 2, 7, 14, then you have 3, 4, 12, and 3, 9, and then you have this one, and you have 1. Okay, now the prime factorization of this number is 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 7 multiplied by 7. Now start making the pair of prime factors. We have learned all these things in our previous video tutorials. Now we have three prime factors, 2, 3, and 7, of which only 2 and 7 are in pairs, but 3 is not in pair. It means that this number is not a perfect square. So this is clear. Now the next part of the question. If not, find the smallest multiple of 2352, which is a perfect square. And then find the square root of the new number. Okay. So we have established that 2352 is not a perfect square. It's asking what is that smallest multiple of 2352. Now multiple of 2352 means what? You have to multiply some number to it, right? Some number. Let's say that number is a. We don't know what's a. We have to find out that, such that when you get the new number after multiplying this 2352 by a, that is unknown to us, and when you get the number, that number is actually what? A perfect square. And then you have to find out the square root of this one. Okay. If you look at this prime factorization, it's prime factorization of what? It's prime factorization of 2352. Okay. If we multiply this 2352 by 3, then what will happen? This will happen. 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 7 multiplied by 7. We are now creating a pair of 3. This was already here. This 2 was already in the beginning. Now we have created this one by multiplying this number by 3, and we already had this one, 7 multiplied by 7. Now tell me, now is this not representing a perfect square number? Clearly yes, it is. What's that number? Simple, multiply this one. So when you multiply this, you get, I'll write it here, 3 times 2 is 6, then 3 times 5 is 15, 3 times 3 is 9, and 1 10, 7056. 7056 is that multiple of the smallest multiple of 2352, which is a perfect square. Right? Now, what's the square root? That's really very simple. We have learned all these things. Take 1 2 from here, multiplied by 1 2 from here, multiplied by 1 3 from here, multiplied by 1 7 from here. You get 2 times 2 is 4, times 3 is 12, times 7 is 84. We have next problem. Find the smallest number by which 9408 must be divided so that the quotient is a perfect square. Okay, find the square root of the quotient. 9408 is not a perfect square as per the quotient. Let's find out the prime factorization again. Why? Because here we have to divide this number by some number so that you get a perfect number. In all such quotients, always go for prime factorization method. So you have 9408 for 8 7 14 2 0 2 4 8 2 4 2 3 6 2 5 10 2 2 4 2 1 2 2 1 2 2 7 14 2 16. You have 2 5 10 2 8 16 and 2 8 16, 2 2 4 2 9 18 and 2 4 8, 2 1 2 2 4 8 2 7 14, 3 4 12 and 3 9 27. You have 7. You get this. Okay, so 9408 when written in the form of prime factors will be 2 by 2, then multiplied by 2 multiplied by 2, then multiplied by 2 multiplied by 2, then multiplied by 3, and then multiplied by 7 multiplied by 7. Okay, so this is in pair, this is in pair, this is in pair, this is in pair, only 3 is not in pair. Okay, but here it's not asking the smallest multiple as it was in this question. It's asking now what can you divide from this number so that you get the quotient which is a perfect square. Okay, this is the prime factorization of 9408. If it had been asked to us that what will be the smallest multiple, in that case you would have simply multiplied by 3 as we have done here, right? So that we can get a pair of 3, therefore your number will be the perfect square. But here it's not asking the multiple, it's asking now the quotient one. Okay, can we get rid of this 3 if we divide this whole by 3? This is the sign of pair, so don't get confused. Like, it's not that numerator and denominator line, right? So this is, if you divide by 3, now this gets cancelled, right? The basic division method. So what you will get? You will get 2 multiplied by 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 7 multiplied by 7, right? Okay, so tell me, when you have actually divided this by 3, it means that you have actually divided 9408 by 3, right? So when you divide this by 3, so you'll get some number, right? What will be actually the number? That's actually the quotient. This is what? This is 9408 divided by 3 actually. So what you'll get? 3 times 3 is 9. Then you get 4. 3 times 1 is 3. You get 1 and 0. 3 times 3 you get 9, 1, 18, and this. So this is what actually? This is quotient. So you are getting 3136 as a quotient, and it's actually what? It's the same thing here. you're getting by division from here. So you can cross check it. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, then 64 times 7 is 28, to 7 6 42 and 44, then times 7 is 7 times 8 is 56 and 5, 7 4 28 33 and 3, 7 4 28 and 31. You're getting this number. It means that this is the quotient, and this quotient is a perfect square, right? Now we have to tell the square root. Simple. This is in pair, this is in pair, this is in pair, this is in pair. So square root will be 1 2 from here multiplied by 1 from here multiplied by 1 from here multiplied by 1 7 from here. 2 times 2 is 4, times 2 is 8, times 7 is 56. Okay. Find the smallest square number. Take note of this. Square number and smallest, which is divisible by each of the numbers 6, 9 and 15. It's not just asking smallest number which is divisible. In that case, you'll simply find out least common multiple, right? LCM. But here it's asking find the smallest square number. Okay. Now before discussing this problem, let me ask you one thing. If 2 multiplied by 4 is equal to 8, it means what? 8 is a multiple of 2, right? 8 is a multiple of 2, and 2 is the factor of 8, is a factor of 8, right? 2 is a factor of 8. Now tell me, 8 times 2 is what? 16. Or you can take any number, not just 2, you can take any number. Let's take 3 here. 8 times 3 is 24. And 24 times, let's say, 4 is 96. Okay. So 8 is the multiple of 2, and therefore 2 is a factor of 8. Now 24 is a multiple of 8, but if you notice, 24 is also so it means that 8 is a factor of 24. But here if you notice, even 2 is also a factor of 24, right? Now this 24 is actually the multiple of 8 in this case. Now 24 times 4 is 96. 96 is a multiple of 24. It means that 24 is a factor of 96. But if you notice that this 96 even is the factor of 2 is a factor of 96 also. It means that if you go on multiplying this particular multiple and you try to find out the multiple of this number itself, then that will be divisible by divisible by 2 only. That is a factor. Okay, and why this is important, I'll show you. So let me remove this. You have 6, 9 and 15. Let's find out its LCM first. So the first step is take LCM. So 6, 9 and 15. So you have 3 times 2 is 6 times, first we have to start by 2. Okay, so what is the LCM? 2 times 3 multiplied by 3 multiplied by 5. You get 2 times 3 is 6 times 3 is 18 times 5 is 90. Okay, now this 90 you have to check whether 90 is a perfect square or not. So check it. 90, if you find out its prime factorization, you get 2 times 45, then 15, then sorry 5 and then 1. So here the prime factorization is 2 multiplied by 3 multiplied by 3 multiplied by 5. Only this prime factor 3 is in pair, whereas 2 and 5 are not in pairs. It means that yes, 90 is not a perfect square. Therefore, we can't say that this is the smallest square number. This is the least common multiple. 90 is the least common multiple. But if you look at this number and if you see what we have actually done in this problem, it's something similar to that one. This is 90. What can we do to this number so that it becomes actually a perfect square number, right? So that it becomes a perfect square number. So if you multiply this number by, or let me do it here. So this is 90 divided by 2 times 3 times 3 times 5. Okay, if we multiply this 90 by 10, then 10 is actually what? 10 is actually 2 multiplied by 5, right? So if I write 10 here, that 10 is actually what? That can be written as 2 multiplied by 5. Okay, so now you get 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5 multiplied by 5. Okay, so you have this here, you have this in pair, you have this in pair. Okay, what is actually, now this is a perfect square. Okay, we have made this one as a perfect square, but what is this number actually? This is actually 900, right? Since we have multiplied 90 by 10, it means that this is the multiple, this 900 is a multiple of now 90. This 900 is a multiple of 90 that has now become a perfect square. But what's the important thing? Important thing is, since 90 was divisible by 6, let me take the simplifying color, by 6, by 9 and by 5. 90 was the least common multiple of 6, 9 and 5. It means that 6 is a factor of 90, 9 is a factor of 90 and 5 is a factor of 90. Okay, so when you find this 900 that is the multiple of 90, it means that 6 is a factor of 900. Remember, we have discussed that one, 2 times, 8 times, 3 times, then 24 times, that one. That what I was trying to explain you was that if you have a multiple, then you again find the multiple of this multiple, then even the final number will be divisible by the initial ones. That is, 6 is a factor of 900, your 9 is a factor of 900, and your 5 is a factor of 900. Why? Because 90 is the least common multiple of 6, 9 and 5, or the common multiple of 6 and 9, 5, and 900 is itself the multiple of 90. Therefore, 900 will also be divisible by 6, 9 and 5. And that's what it's asking. Smallest square number. So 900 is the smallest square number, which is divisible by each of the numbers 6, 9 and 15.